Hello, everybody. My name is Jaron, as Patrick said, and today I'm here to share with you, for the first time ever, this presentation, where I'm just kind of presenting the steps I took in order to find a CVE from Apple. So for those of you whose brains are fried at this point, and you've seen a lot of reverse engineering over the past few days, I have good news, and that is that this bug that's led to some pretty cool stuff does not actually require any reverse engineering at all. In fact, if there was a CVE for Dummies book, this CVE would probably be in it. So you'll see as we kind of get deeper into this. But so the vulnerability here is actually based on package kit, so to understand what we're going to do, you first kind of have to understand how a PKG file works. So just a little recap for that. Some people have touched on it the past few days as it is. But essentially a PKG file is if you want to install some software from a vendor, that vendor will pass you this tiny little PKG file, which you then open. It's opened by the installer, and you install the software pretty quickly. So what a PKG file is nothing more than a XAR archive that actually has a specific structure to it in terms of file names and folder names. So we don't need to touch on all of them here, but the most important inside of this, if you were to take a PKG and kind of expand it, you would see you'd have a folder there in the root of that PKG called something.pkg. Now this is actually a folder, even though it has a PKG extension, and within that, one of the most important items you have is the payload, which is a compressed file, gzip that holds all your binaries and everything, whatever you're installing to the disk is located inside that compresses gzip. But more importantly, what we're going to focus on is inside of that folder, you will also see a scripts directory where there's generally a pre-install and post-install script. Not always, but a lot of times these are two of the scripts that come packaged in a PKG. So pre-install, and both of these do what you think they would. Pre-install, when you're installing a package, the pre-install, you can put anything you want in here. It can be written in any language, so long as you know that language is going to be on the system you're running on. So a lot of times it's bash. And pre-install, you can go through, you can check, you can make sure certain things are plugged into the system, you can do certain verifications before you actually perform your install. Post-install works the same way, except obviously it runs after the install takes place. So those are what we're going to kind of be tweaking with the most today. Two commands you got to be familiar with, really one executable, and that's PKG util. Basically, PKG util lets us take a package and expand the contents to a directory of our choosing. And then PKG util flatten, after we've modified those files, PKG util flatten will turn that back into a package for us. And do all the verifications that the right directory structures are in place and all that, and then we'll get a nice new PKG out of it. So my big question when I started with this was just for fun. I've been doing a lot of testing applications update process to see if you could kind of interfere with them and maybe gain root out of them. I decided randomly to test the installer just to see. So my question I was curious about was, could I convince the installer after it's opened to run my unsigned PKG versus the PKG that was actually opened? So here I'll just walk through this video, and we'll get into the real demo later. But so first thing I did is I actually went online and I just grabbed I did some searches in VirusTotal for a small PKG file, something I could run really quickly, something I could test with easily. If it failed, I could start over really quickly. Anything online I could find. So I came across some random software. To be honest, I don't even know what it does. I would not recommend just running random software from VirusTotal on your system, but this is how I did my testing in a VM, of course. So here I'll just open that PKG and show you. It is in fact signed by a developer. Don't know who this is. This vulnerability or this bug isn't related to them at all, so don't worry about that. So we'll go ahead here and we'll close that, and now we'll take this PKG and we'll expand it to a temporary directory called temp classroom setup. We'll take a quick look inside of that, and we see a release.pkg folder. And inside of that release.pkg, sure enough, we have a scripts directory, and we see there is a post install script, which we'll just go ahead and modify. So in here, in the post install script, we're just going to say echo who am I, whatever, is my name, and we'll throw that into temp hello. So essentially, if this kind of works, if we're able to kind of hijack the install process, and we have a file at the end called temp hello, we'll know that we successfully were able to pull this off. So this is a flatten command. We're going to take these modifications and turn them back into a PKG. So now you see on the desktop over there, we have two PKGs, one classroom setup and one classroom setup new.pkg. So here we'll go ahead, we'll open, I'll show you I've opened my my modified package. Obviously it's not signed, we've modified it and we've recreated it. We don't have a signature, we can't sign it, so it's not signed by us. It's not signed by anybody. And then we'll, from here, we'll open the original classroom setup.pkg. Which of course, as I already showed you, is signed. Now we'll go ahead, we'll take that PKG that we just opened and we'll rename it. You can also delete it, do whatever you want, just get rid of it. Just make sure it's no longer has the same name. And we'll take our modified version and we're going to give it the file name that it expects, the file name that it thought was opened, just classroom setup.pkg. So if we run it from here, we go through everything, we agree. It requires root for some reason, whatever this PKG is. The user enters their password. The install takes place and finishes successfully. If we take a look at the temporary directory, we see that we do in fact have a file called hello. And inside that file called hello, it says root is my name. So this is pretty neat. Like it's again, it's just a little bug. But what's even cooler, and we'll get into why this is cooler later, if we take a look at the signature, it's still under the impression that it ran that post install script as though it was signed by a real developer, when in fact we have no signature at all, right? This was completely unsigned code that we just added, and then we swapped out the PKGs. So this was a neat bug, and I decided, like, let's take this. Let's at least, it's kind of minor, but let's take it and let's weaponize it anyway. Let's turn it into something fun. So this is just a really hacky bash script that's going to be really noisy, but it's just a proof of concept, right? But essentially our goal is, can we modify a PKG in real time as a user tries to install a package? If we're an attacker who's already on the system, maybe trying to escalate or for whatever reason. So here, the first thing we do is we just run psaux and we look for an installer to open, just in a huge loop. If we find an installer was open, we capture the PID, and then we will open that PID using lsoff and take a look for the PKG file that was actually open, the path to the PKG file. After that, we'll grab the PKG file, expand it to the temporary directory really quick, and then we'll go through each folder that we find in that directory and look for a post-install script. If we find a post-install script, whatever's in there, we don't know what language it's written in. We're not sure. It could be Python, it could be Perl, it could be Ruby, it could be whatever. So we're going to wipe it out because we don't know what's in it, and we're just going to put a bin bash header at the top. And then we'll put the hello, my name is whatever user we're running as, to the temp hello location. And then finally, we'll take that and we'll repackage it back to the original file that was open. So I'll just show how that works really quickly. If my VM didn't run away from me. Uh-oh. All right, this is going to be a little tricky, but let's see if I can make it work. Okay. So, like I said, PKG injector. Well, first I guess I'll show you, just to show I am a test user, and then the temp hello file does not exist. And I go ahead, run the PKG injector. So as an attacker, we're in the background, we're running this, and somebody comes along, the user comes along, and they try to install a PKG of some type at any point. And you can see in the background, it runs within a matter of seconds, right? We've modified the PKG kind of in real time as it's opened, and then we've replaced it. So that's already been done. And so long as we can do that quick enough before the user gets to the real install process, then whatever's been modified will be what gets installed. So we're still good all the way up to this point until we hit install. So long as we've modified the PKG by this point, the user is going to install whatever we've told it to install. It asks for my password again, so as a user, I'm obviously going to enter that because I have opened this package on purpose in some sense. Don't worry about that, unrelated. In fact, I'll even hit deny. Was successful. Is still signed. Great. And then we can do, like before. Hello, my name is Ruth. So, so here we've managed to just inject into this in real time, which is pretty neat. But with this bug, you know, it's cool, but why, as an attacker, why would I really, you know, wait for root when I could just throw a pop-up or something like that? It's not too convenient. How often do you really install a PKG on your system? It takes a while. So I wanted to take this, and I wanted to go one step further with it. To see if I could abuse this bug even further. So I'm going to go ahead and reset that. Try to fix the monitor better. So anyway, trying to take this to the next level, I thought, what could I really do here? And it occurred to me that the answer is actually right on Apple's website of how you can abuse this bug. And that is, if you read up on system integrity protection on Apple's website, it tells you right there that the only way to write to SIP protected directories is if you have a PKG that's signed by Apple. So we have verified that we're actually able to kind of mimic any developer we want, so long as we have a PKG that's signed by them. So my question was kind of, can I take this and without any user interaction, now that I have root access, can I take this and without any user interaction go from the root user to bypassing of system integrity protection? So I went to Apple's website. It just so happened that at the time I was working on this, they had released something called Pro Video Formats, which is just a number of codecs, updated codecs that you can download and install. And this was right at the right time. And it puts those codecs in SIP protected directories, so I knew whatever signature had to be there should in fact exist. Or whatever logic had to be in place for this to happen should in fact exist. And I took that PKG, I expanded it, I went to the post install script, which was in there, and I just put hello from Apple sign package once again to temp hello. So if I could get this file to exist, that would also mean that once again this could be pulled off even with an Apple sign package, which at this point is what I was trying to verify. So here's the first attempt. This is real intense stuff, but if you come with me to line 7, you'll see we're going to start the installer, right? We're running the installer command with this Apple sign package. We're going to wait half a second, and we're just going to swap it out and see what happens. We're going to swap it out with our modified package and just see if this works. Why not? No surprise, that was a flop. Didn't have any luck, and this was different because I was dealing with the installer command versus an actual GUI, and I knew the race condition would be a little bit different here. So what I did is I went to the log at var log install.log and took a look at what's going on to see if I could get something a little more verbose out of this. And what you'll actually notice here is the installer The installer here highlighted in green. Generally, when you install software and you go take a peek at the install log, you'll see just a huge entry of installer items, like you just one after the other for a long time, right? What's different about this, here highlighted in red, is system install D takes over. So what we can assume, just by looking at the log, is that the installer runs, if it sees and verifies that it's dealing with an Apple sign package, it then passes that package off to system install D, where system install D then handles the writing of the SIP protected files and just handles the Apple sign package in general, as where installer by itself can't do that. And the reason for that, if you take a look at the system install D entitlements, you'll notice that it does in fact have the com.apple.rootlist.install.heritable entitlement. So system install D is able to write to these SIP protected directories thanks to this entitlement, as where installer is not able to do that. So here's just a little more details on what went wrong. Honestly, it's still a pretty vague error and wasn't all that helpful in trying to sort out what was happening. But the answer was still buried here in the log, or at least my answer for this hacky bashfulness I was putting together. And primarily down there at the bottom where I've highlighted extracting file. So here you can see that system install D is taking the PKG, the legitimate one that's trying to be installed, and it extracts the contents to a PK install sandbox manager. Now this temporary directory that is kind of created for this install is also SIP protected, since system install D is able to do that. So once the PKG has been extracted to this temporary directory, it can no longer be modified. We're too late. We've lost the race condition at this point, and we can't do anything here. So that brings me to my next Hail Mary, which was the same exact thing, except this time we're going to watch the install log for the words extracting file. If we see those words, that's when we're going to make the swap. So we're not making a blind swap here anymore, but this is still pretty much a Hail Mary that you wouldn't believe, but actually worked. So this is the installer running. After it finishes, I just go to cat that file, and sure enough, it exists. So the file we wanted to work. So we've now verified that we can run code as though it was signed by Apple. So let's bring this all together at this point. And let's try to do that for the demo of someone if I can see my screen. No. This is the problem. All right, we'll make this work. So the first thing we're going to do as an attacker, like we're on the system in some sense, we've managed to get root, and we've brought this Apple signed PKG over to the system. So we'll do a PKG util, and you might, as an attacker, you probably bring this over weaponized already. But just for the sake of demoing this, we'll do it in real time here. So we'll do a PKG util, and we'll do expand. We'll take that pro video format to Apple sign package, and we'll throw it to a temporary directory. We'll just call it provids. And then we will take a look at what's in that. Temp provids. So we can see there's actually 3 PKGs inside this single PKG. The MXF plugin, I happen to know, holds a scripts directory in it, as well as a post-install script, which is written in Perl. Thanks, Apple. I'm not going to write that. Instead, I'm actually going to delete that, and we'll create a new file. And we'll do bash. And what we're going to put in here is not a hash. That was a mistake. Let me. We're close. All right, there we go. What we're going to put in here is this happy little reverse shell that'll just dial back on the local host to port 8080. again, really hacky stuff. We'll save that up. Just so we know, this is important. You want to make sure that the file is going to be executable. And then we'll do a PKG util, and we'll flatten the stuff we just modified to a new file. We'll call it PKG, or we'll call it provids modified.pkg. All right, so the last thing we need to take a look at is what we're actually going to execute here. And that's our script, pretty much identical to what I already spoke to. But we're going to start the installer. We're going to sit there and wait until we see the words extracting file inside of the install log. And then we're going to make that swap from we're going to swap the Apple sign package for our unsigned modified package. And then we're going to sit there, we're going to start that in the background, and we're going to kick off a netcat listener on port 8080 and hope that we get a connection and that the demo gods are in my favor today. But so what should essentially be happening here is the installer will take the package, it will see that it's signed by Apple, it will pass that off to system install D, which has the privileged entitlements, and then when system install D, we'll make the swap at that point, and when system install D runs our post install script, what we should have is a privileged shell connecting back to us that can bypass it. And here we go. Good luck. Now remember, we do need to be the root user for this. We've already assumed we've gotten root, whether that be through the same exploit or through some other means. And we see that we do have a shell. This is a good start. I'll do CSR util status just to ensure that SIP is enabled. And sure enough, it is. But I should, at this point, still be able to do something like hi to a system integrity protected location, like so. I don't get any errors. Also a good sign. System load.txt. Let me see that. And then you see like 10 minutes later, the installer actually finished the install because we started that in the background. Yeah, what's cool there is obviously if we exit out and we are root, we shouldn't, even as root, we shouldn't be able to delete that file at this point. Of course we do. Nothing. So this is actually just an example of how you can take kind of this silly little bug and continue to pursue it and try and turn it into something cool. It's also, this is still relevant to us because for those of you that saw my talk last year, actors out there are looking to blend in with the operating system as best they can. So SIP, despite the fact that it is kind of basic idea and that it does just protect certain locations on the hard drive, it is still important, I would argue, and a smart move on Apple's behalf, because actors are checking these locations and are checking to see if system integrity protection is enabled. And if it's not, they're going to bury as deep as they possibly can versus, just hiding somewhere in the launch game's location. So, that is it. That is all I have for you guys.